everyone. We're going to talk about ICP in this video, and we're going to focus more on the I and the C. Remember, ICP stands for inductively coupled plasma, so we're going to focus on inductance in this video. I do want to remind you of what the torch looked like. Remember, the torch can have two geometries in an instrument. It can have this so-called radial geometry, or as an R instrument, it can have this axial geometry. But whether you have radial or axial geometry, the tip of the torch is going to be surrounded by radio frequency coils. These coils here, these so-called RF coils. And for the rest of this video, I want to explain to you the role of these RF coils. And again, we'll be talking about inductance. So get ready. Here is a cutaway view of the torch. This is where that sample or that nebulized sample enters the torch. And you can see that there's also some argon flowing this way. And what you're looking at here is a cutaway view of those radio frequency or RF coils. And there's this word induction, radio frequency induction coil. What I have never said yet is that there's going to be a current that flows through these coils, and the current oscillates at radio frequency at either this one or this frequency at this power, but you don't need to remember any of this. What I want to do on the next slide is try to understand inductance. And I had to go back to a physics book to try to think about how to explain that. Can you imagine doing this experiment where we have an iron ring, and attached to the iron ring we have a wire. We're going to call that the primary coil, and it's attached to a battery. And on the other end of the ring we have another wire that we're going to call our secondary coil, and it's attached to a galvanometer or a measuring device. So I think you wouldn't be surprised that if we were to close this switch, you wouldn't be surprised for current to flow through this primary coil. That shouldn't be too surprising. But would you be surprised if current flowed momentarily through that secondary coil, even though it's not connected to a battery? So how can we explain why current flowed through this secondary coil again, even though it wasn't connected to the battery or any power supply? Something about the current flowing through this primary coil must have induced, hence the word inductance, something about the current flowing through this primary coil again must have induced a current to flow through this secondary coil. So what could have induced that current? The magnetic field. And magnetic fields are often given the symbol B. Anytime current flows through a wire, there's a magnetic field associated with it, and that magnetic field induced a current to be carried through this secondary coil. So thinking back to the ICP and the torch, what do you think functions as the primary coil? I hope you thought of that radio frequency coil. Current flows through it. A magnetic field is produced. That magnetic field induces a current, which I'll just call a secondary current. But what behaves then as the secondary coil in the ICP? What could conduct that current induced by this RF coil? The only thing there is the plasma. So the argon ions and electrons in the plasma behave as the secondary coil. And here's a law that you may have learned in one of your physics classes, but we won't worry about it so much. Let's see if we can understand this process of induction or inductance using the torch as our figure. Here it is. So again, here are your RF coils, and a current is going to flow through those RF coils. You have a power supply to do that, and then a magnetic field is produced. These lines here, these are your so-called magnetic field lines. A magnetic field is produced, and then that magnetic field induces a current, and the only thing there to conduct that current is the plasma. Specifically, the argon ions and electrons conduct that current induced by the magnetic field. And then there's one other thing to think about. We said earlier that anytime current flows through a wire, there's going to be a magnetic field associated with it. But another thing that happens anytime current flows is there's going to be resistance to that current. And I don't know what your intuition is telling you about this process, but would you think that gaseous ions and electrons are a good conductor of current? Probably not. So the resistance to this current, and I mean this current here that's being carried by the argon ions and electrons, the resistance to that current results in heating of the plasma. Here's another definition that maybe I'll let you read about induction heating. Yes, it is heating without physical contact or heat being transferred through electromagnetic waves. I think those are also nice ways to think about it. But again, in this slide, I hope you got the process. Current flowed through that RF coil. A magnetic field was produced, which induced another current. The only thing there to carry it were the argon ions and electrons in the plasma. They start moving in this annular path, and resistance associated with this current resulted in heating. That's all I have to say about inductance, I think. Thanks for listening.